Good evening, be enthusiasts. Good evening, minions. Welcome to the first session of the Pathfinder series, where we are going to train you throughout the year for the next year's examinations. Now, it doesn't matter whether you are preparing for JEE, KVPY, NEET, boards, any kind of competitive exam that you're preparing to. This is a long-term series which is called as the Pathfinder series for all the 11th to 12th moving students, so that next year when you're going to write the examination, all these sessions, all these curated series, all these lectures are going to help you. All this with me, Shreyas, your master teacher for physics at Vedantu going live. And guys, I have been training and coaching students for a very long time, even before Vedantu, and I have produced some amazing results under my mentorship. In fact, many of my students have not just got into IITs and NITs, but in fact they have secured top 2-digit ranks. And I really hope that this series brings in the change. Hello Enthuse fan club, hello Neha, hello Yalini, hello Avinash, hi Shake It Off, hi Venkatachalan, hi Kirtiharan, Ronak, hello Harshini, hi Stravs, hi Gwen, hi Likita, hello Amu, welcome, good evening again. I must say hi Vignesh, thank you Vignesh so much, glad to hear that. Hi Srinu, hi Amar, hi Rajani, welcome aboard. And guys, if you want to know more about me, you can definitely follow me on my Instagram handle, and that's Shreyas_Vedantu. It's also there in the description box below. You can check it out and follow me out there. And before we begin today's class, do not forget to smash that like button, because it really means a lot when we get all your love, support, your likes. So please hit the like button. And if you enjoy watching all the lectures out here, do not forget to share and tell your friends, spread the word around, all right, with all your friends and relatives. And if you're new to this channel, do subscribe to our channel, because we are going to prepare you for all the long-term in these long-term courses for the next year exams, even the examinations which are going to happen this year. Welcome. Hi Syed. Hello. Yes, this is the first lecture from the scratch. Hello Ala Arista. Welcome. Now, remember one thing, yesterday the same session was conducted, but unfortunately due to tech issues we had to cut it down. Now I know a lot of problems happened. Some of you were not able to understand it or see it clearly because of the tech issues from the YouTube side, and I showed you my internet was working really fine. So that's why I decided let's get from the scratch, and some of the people might be new out here for today's lecture, so it's okay. Some of the part might be repeated. The first few minutes will be repeated, but that's okay. It will at least be a revision for all of you. But remember, the later half is all new. So a lot of new concepts which you are going to learn. So do not forget that even if you find a lot of points to be repeated, understand from the previous session, it's okay. It will just be a revision. So let's begin with it. And do not forget that the V.O.T.E, which is the Vedantu Online Talent Examination, is happening right now. The next date where you can appear for the Vedantu Online Talent Examination is 11th April, and then is 18th April, where you can win lots of prizes from a pool of 500 crore rupees, and also become the CEO of Vedantu, or go to NASA, or win Xbox or PlayStation and stuff like that. So the link for joining and registering for online talent examination is there in the description box below. So please do check it out. So here is the Pathfinder series schedule. All right, it has been tweaked a little bit. So today, charges and charging, then force and field, then potential energy, then dipoles, field lines and equipotential surface, and then Menti quiz. So this is the schedule for the first chapter. So after every theory, we are going to have a Menti quiz, and this theory lectures also include problems for JEE Mains as well as JEE Advanced type. Keep this in mind. So understand, this is not a JEE Mains series, this is a JEE Mains plus Advanced kind of a series. So both kind of questions are going to be there. And for Zero to Hero series, we are covering all the chapters in short, like one short series for all the 2021 aspirants. So before your April examination, all the chapters would be completed. You can find all the lectures in the playlist, which is beautifully arranged on our channel. And the last one, the Killer 5 series, which is the JEE Advanced series, starting this Saturday. So let's begin with our class. Yes, V Enthuse fan club, this lecture is also enough for CBSE boards 2022. Yes, cool. Let's get going. I know you're not late by a lot of amount. Don't worry, you just missed the little bit of introduction part and the welcoming. But now I'm just starting the theory part. All right. Hello, Ninad. Welcome. I'm very good, Niha. Thank you very much. Nice to see all of you out here. Hello, Aranya. Welcome. I'm very good. And with all your love and support, we are going to do even better. Let's begin. Now, like I said, some of it might be repeated, but that's okay. It's a revision for all of you. Remember, everything around you, your hand, your table, this board, the wall, the ceiling, anything, your pen, it's all made of atoms. And what are atoms made of? Tiny particles. And these particles have different properties like mass, charge, magnetic properties, etc. Here we are worried only about the electrical properties. Long time back, people used to wonder why things attract or repel each other. For example, you take a comb and you comb your hair, and then you see that it attracts bits and pieces of paper. Or when you rub a rod on some woolen or silk cloth, then it's seen that the rod or that cloth repels or attracts some other objects. So people used to wonder, and later on in the last 200-300 years, it was understood that these are basically due to charges, and there are two kinds of charges. Actually, there is a third type as well, but that is something called as a neutral charge or no charge. So an atom is made up of three kind of things. All right, one is a neutral quantity, so it's not exactly a charge, it's chargeless. All right, it's chargeless. And the other two kinds are protons, which is positive charge, and the other one is electron, which is negatively charged. So these are the different kinds of charges. So all my classes are going to be at 9 o'clock. And good evening, Kartika. Welcome. Yes, wet hair. Yes, definitely Ninad cannot do that. Yes. Oh, nice to see you, Asmita, out here. Hello, Kiran. Yes, Rajat, as soon as Wazim sir is out of the hospital and out of COVID situation, he's definitely going to start. In fact, I wished him yesterday only for his birthday, and he was also missing all of you, and we were also missing him. And I just called him and told him how he was feeling, and he's feeling a little bit better now, and he's all excited to start the classes with all of you. Don't worry. Okay, so now, no, you don't have quarks, gloom, plasma theory, Nina, in 12th. All right. Yes. Okay. So all the lessons are there. All the lessons, Munna bhai, are going to be there. Yes, Wazim sir is fine, Hariharan. Yes, he's fine. Now he's feeling a little bit better, but he will take some time to recuperate and actually conduct the classes, because trust me, taking classes on YouTube with all the lights around, I don't know whether you realize it, it takes a lot of energy. Trust me on that. Okay. Now, having said that, let's also look at some of the properties of charge. So just now, what did we see? There are two kinds of charges. One is positive, one is negative, and the third one is chargeless quantity. Now, what are the different properties of charge which you need to keep in mind? Because these properties will help you make equations. So that's very important. So let's see some of the properties of charges. Number one, it's pretty much standard. Oppositely charged materials attract each other, like positive and negative will attract, whereas like charges, positive or negative will repel each other. Keep this in mind. Okay, so hello Vijay Kumar, welcome back. Yes, definitely Alni and others, he's definitely going to get well. So positives repel, negatives repel, negatives attract. That's the first property. And guys, you can also simultaneously make notes, because making notes is a good practice. You need not have to write everything over here, because you're going to get all of this in the PDF in your Telegram group. Again, the Telegram group's link is there in the description box below. So do not forget to check it out. Now, having said that, let's go to property number 2. The property number 2 is charge is always conserved. Very important. Understand that. Very important. So Venkata, there was a problem yesterday. That's why we are redoing this class, because a lot of people could not understand or had buffering issues. And plus a lot of the lecture was remaining. So we are redoing it so that it's there properly in your playlist as well as the recorded session. Now, for example, if this is an isolated system, if this is an isolated system. Now what is the meaning of isolated? The word isolated means that nothing can enter in, so nothing can enter in, nothing can exit outside. So it's not allowed. Nothing can go in, nothing can come out. Like your room which is locked. Nobody can come in, nobody can go out. All the windows, doors are sealed. So if you have a sealed environment, then whatever charges are there will always be preserved, no matter what happens. For example, this has a charge of +2. Let's say this has a charge of +3. Let's say this has a charge of -1. Now if you add all these charges, +2, +3 is +5, +5 -1 is +4. So the total charge of the system is +4. Keep this in mind. So this is the charge of the system. This is the total charge of the system. Now let's say by some process these people exchange their charges. Yeah, very good, Ninad. So let's say by some process they can exchange their charges. So for example, now to keep this +4, see what will happen. Let's say this becomes -3. Let's say this becomes -3. Let's say this becomes +5. Example. This is +5, this is -3. What is the total charge here now? +5 -3 is +2. But actually, the total charge of the system should be +4. So what is that quantity which will add to make the total charge +4? Excellent. Some of you have already answered. Okay. Very good. Very good. Very good. +2, guys. Excellent. So +2. That's the answer. Excellent. So +5 -3 is +2, +2 +2 is +4. That's the answer. Similarly, anything else that will happen, say for example, this becomes +7, this becomes +2. Example, this is +7 +2 is +9. So what should you add to get +4? So what will you add to 9 to get +4? You should add -5. So this must be -5. That's how this works. Very good, Tanish, Ninad. Very good. Excellent. Very good. Very good. We Enthuse fan club. Good to see. Good. I mean, it's nice to see things on full screen, and that too on HD quality. It looks very nice and neat. So guys, if you have very good internet connection, good data plans, please watch all our lectures on 720p. All right, I'm streaming at 720p. Okay, so that's the story of the charge is always conserved. Keep this in mind in isolated systems. Very good. Now, the third property, charges are quantized. Charges are quantized. Okay, Shimon sir will be also starting very soon. Okay, don't worry, he will be also starting. Okay, now imagine, guys, I tell you, you can only have 3 rupee coins. You can only have 3 rupee coins. That's it. There are only 3 rupee coins in this world. Can you somehow transfer 5 rupees to any person? If you just have 3 rupee coins in this world, can you transfer 5 rupees to a person? No, right? You cannot say, oh no, I'm going to break that 3 rupee coins into 3 parts and one part of that 3 rupee coin is 1 rupee. You will get one tight slap. No, you cannot do that. Definitely not possible. Oh my god. So people, yeah, don't get scared. 1080p is definitely going to loot your data. But I hope you have good data plans out there. But it's okay. Anyways, you can always at least watch at 480p. Now, can I transfer 12 rupees? Yes, I will use 4 3 rupee coins and I can transfer 12 rupees to a person. Yes, that's allowed. So 5 rupees was not allowed. 12 rupees was allowed. Can I transfer 100 rupees? Well, obviously it's not a multiple, so it's not allowed. Can I transfer 3000 rupees? Yes, 3000 is a multiple of 3. Correcto. Yes, very good, very good. Yes, excellent. So the same way, charges are quantized. Quantized means, there is a minimum base amount, there is a minimum denomination, and anything else is a multiple of that base amount or that base denomination. Understand that. Now the denomination for charges is E. So the charge on a body can be E, 2E, 3E, 4E, 5E, or -E, -2E, -3E, -4E, and anything else. but it can't be minus 1.7 E plus 2.8 E plus 307.65 E. Not allowed. It has to be an integer times of E, whether positive or negative doesn't matter, because charges can be of two types. So the charge, this is the charge on anything, has to be plus or minus n times of E. This is the smallest value possible. This is the smallest charge possible, and the value for that is 1.6 into 10 to the power minus 19 coulomb. Keep this in mind. This is the smallest possible value. What is n? Well, n, it's nothing but an integer. Keep this in mind. Okay, I hope everybody has understood this. Yeah, 0 is also allowed. Yeah, I mean 0 charge is like it has no charge. Yes, 0 is also allowed. All right. Okay. No problem, Shreyas. Join in. Yes, it can't be 3.5 E. Yes, Nina, it can't be. It can't be. Yes, this is called as the smallest charge. You can also call it as the quanta. This is the smallest quanta. This is like, yeah, the smallest number possible. That's why I'm saying the charges are always quantized. Very good. Yes. Now, having said that, let's get going to the next property, fourth property. Whenever charges are transferred, when I say, oh, this body got positively charged, oh, this body got negatively charged, understand what exactly is happening. So, what exactly happens is that, let's say you have a body and this is another body, all right, and each body has positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. What is this? Equal number of protons, equal number of electrons. So that's why I'm saying this is a neutral body. This is a neutral body. But let's say some other body has positive, negative, positive, negative, 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 positive, negative, positive, negative, negative. Do you see that there are excess electrons over here? Do you see there are excess electrons over here? Very good. Do you see that there are excess electrons over here? So I will say this is negatively charged. This is negatively charged. Now understand, if I rub them or somehow the charges move from one place to the other. Let's say this charge goes here and this charge also goes here. So you know the charges are moving from one place to the other. So what exactly is moving? It's the electrons. So the electrons are basically flowing. Understand, the electrons are exactly flowing from one to the other. Understand that. Yes, only electrons are allowed to move. Protons, they are a part of the nucleus. A proton is not allowed to ditch an atom. A proton is not allowed to be added to that atom, because if it does, then the element itself will change and then it will become a nuclear reaction. And you all know what happens when there is a nuclear reaction. It's not so pleasant. So guys, electrons can be exchanged, protons are not to be exchanged. All right. And similarly, understand guys, if there is another body, all right, and let's say I say it is positively charged, that means there are a lot of electrons which have ditched them, and let's say this is positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Now this is a positively charged body. This is a positively charged body. That means there is deficiency of electrons. Yes. So understand, these pluses cannot move. But yes, this minus can move. This minus can move and it can satisfy this plus. That plus and minus can cancel. This minus can move, but this positives cannot move. Understand that. Okay, I hope this is clear. Very good. Chalo, let's get moving. If you guys have understood, so it's always the electrons which move, protons do not move. Electrons moves from one body to other. Keep this in mind. Let's get going. Abhishek, I'm very good. Thank you very much. Yes, very good, very good, very good. Chalo. Guys, in case you find any kind of lag issues, there are 2-3 things you can do. First thing, refresh. Okay, just refresh. Number 2, all right, reduce the resolution. reduce the resolution. If you are at 720, make it to 480. Don't go lower than 480, things will not be clear. Third thing, instead of live, go 15 to 20 seconds behind and watch the lecture. It's as if it is live only, almost live, 15-20 seconds behind. And the last thing you can do if none of them works, please check your internet connection. And the worst case possible, YouTube might have a problem, but that rarely happens like it happened yesterday. Okay, now charge is a scalar, the unit is a coulomb. Remember, the unit of charge is coulomb and it's a scalar quantity. Okay, so charges can be only added and subtracted just by their values. Nobody will ask you the direction of a charge. If I tell you that, there are three, where did it go? This body has a charge. This body has a charge of +3. Nobody in this world, in their sane minds, will ever ask you what's the direction of this charge. Nobody will ask you what is the direction of +3 charge. If they ask, you should give them one tight slap. Understand? Because charge is a scalar quantity. Plus, when you have a +2e charge, -3e charge, +5e charge, you don't worry about the directions. You don't put the bars over them. Understand, they are just added by scalar addition. They do not follow laws of vector addition. So 2 minus 3 is -1, -1 plus 5. Well, that's +4e. So that's how you do it. Okay. Yes, very good. Coulomb is the unit of, Coulomb meter is dipole moment. That's something else which you'll be learning in a separate session. There is a separate session just for dipoles. All right. So let's get ready for some problems. All right. So whenever you add charges, just make sure you add the values, not the directions. It's insignificant. So guys, those of you who are interested in the 2022 batch, please check out the details in the description box below. The 2022 batch is going to start again. And there are few batches which have already started. I have already started teaching the toppers batch, and I'm going to start a lot of small teeny mini courses, and you will find thousands of courses by so many master teachers out here. And I'll tell you the biggest advantage is that there are two kinds of batches at Vedantu. One is an English batch and second is a Hindi batch. So you can choose which language of instruction you would like, just like we have a YouTube channel for English as well as Hindi students. And after every lecture, there are tests, assignments, and you get the hard copy material, which is Tattva module. And all of this at a very good rate after discount, 43,739 rupees, provided you use the coupon code SHHPRO. So if you have any queries regarding this, please ping me on my Instagram handle. I'll definitely help you out. Any doubts or queries that you have, you can ask me on my Instagram, or you can put up a comment below on this YouTube video after the lecture is over. You cannot post a comment while the lecture is on. Remember that. So let's have a look at the first question. Now some of you minions already know this question because you attended the class yesterday. Okay. Well, Ninad. Okay. Well, we don't support violence. This was just for the saying. Okay. Okay. Chalo. Now, what is the property? One shortly tell me, sir. Vijay Kumar, you can replay back. You can just slide the slider a little bit, even in a live class, and you can see property 1. That's the advantage at YouTube. Okay, very good. Yes, excellent. Many of you have answered. Kya baat hai. Looks like a lot of you were there already. I'm so happy, so glad that you show so much of love and support by coming here. So, balloon B is negative and it attracts. Who attracts whom? Negative will attract positive. Now, if A is positive, that means this balloon is positive. But this balloon is repelling this balloon. That means C has to be positive. As simple as that. That's why option A. Very good. Next question. Let's see how many of you can do this. Come on. Those of you who are there already know the answer, but still. Which of the following charges are possible on a body? Which of the following charges are possible on a body? Okay, already Misha has started answering. Very good, very good. All right. By the way, hint, multiple options might be correct. 1, 2, 3, 4. I don't know. Some of you are already there. Look at that, Amu, Uncharted, and then Rajani. Yes, now it clicked. More than one options are correct. Guys, the smallest possible charge is 1.6 into 10 to the power minus 19. This is the smallest, remember? And now think, Is 6.4 into 10 to the power 19 a multiple of this? Yes, it is 4 times of E. You can see that. It is 4 times of E. Hence, this is possible. 6.4 into 10 to the power minus 20? Oh, come on, this is less than E. So obviously, this is not a multiple of that. It's like that example I gave you. I have only 3 rupee coins. Can I give somebody 0.5 rupees? How can I give somebody less than 3 rupees? And the smallest amount possible only is 3 rupees. Understand that. Same way, the smallest amount is E, so you can't give less than E. This one, guys, this is not n times of E. It might be bigger than E. 2 is not a multiple of 1.6. Multiple of 1.6 is 3.2, 4.8, 6.4, and so on and so forth. This is not a multiple, so hence this is crossed out. And the last one, yes, this will be. Come on, 32. It's going to be a multiple of E somewhere or the other. If you write it as 3.2 into 10 to the power minus 16, then you can see it's definitely a multiple. You can see that. Very good. So this is also the correct option. There will be thousands of charges, by the way, yes, to make it happen. But yes, it's a multiple. This is essentially n times of E. Hence, it is allowed. Yes, A and D are the correct answers. Very good, minions. Excellent. Yes, Uday, I said this yesterday. Why am I teaching again? Uday, remember, I don't know whether you attended the lecture completely. There was a glitch and we had to stop the lecture midway. I couldn't even complete half the lecture. So that's why I'm repeating all of this again, so that, when later on you want to revise, you don't have to find, oh, charges was there on lecture 1 and again the same thing is there on the other day and there is a confusion. I don't know where to study from. And plus, a lot of interruptions happened. So that's why, instead of doing all that nonsense, I don't mind. I will always put in extra effort and I will redo the same thing. But there are a lot of things which were not covered yesterday. Okay, let's get to the next one. 3 balls are taken. A and B are charged. A is positive, B is negative. Arrange all of them in the decreasing order of the masses. Come on, minions. Come on, think, guys. Come on. We Enthuse FC fan club, understand, 32 is a multiple of 16, right? And 10 to the power minus 15 is a bigger number than 10 to the power minus 19. So some multiple of 1.6 into 10 to the power minus 19 will be 3.2 into 10 to the power minus 16. Hence, it is allowed. Okay, very good. A lot of you are answering C. So understand, ball A, ball B, ball C. This is A, this is B, this is C. Now A is positive. Positive means one electron is less or few electrons have been taken out. So electrons have been taken out. B is negative. That means electrons are added. And C, nothing is done. It's neutral. So there is no change. So if you remove something, obviously the mass will go down. If you add something, the mass will go up. And here the mass will not change. So hence the biggest mass is B, and then the decent mass is C, and the least mass is A. Hence the correct option is option C. I hope this is clear. Let's get going. Understood, guys? Yes, very good. Next question. 1 coulomb of charge contains how many number of electrons? 1 coulomb of charge contains how many number of electrons? Hello Muhammad Ali, hello Chiranjeevi, Sujay, welcome. Already started answering. Very good, excellent. And the answer is 6.25 into 10 to the power 18. Very good, minions. Look at that. Guys, there is one lesson to be learned today. If you do the same thing at least twice, do you find it very easy? And aren't you seeing that? Now, why can't you do the same thing with your studies, guys? If you revise 2 times, 3 times, 4 times, tell me which person will not be able to remember the formulas, remember the definitions, remember the concepts, remember the pointers. Do you see that? I hope I have proved my point by just taking the lecture twice. A very important lesson for all of you to be learned today. Do you see that? You're feeling it within yourself. Oh, this looks familiar. Oh, this I can do it. Oh, I know how to do it. This is what revision does. And that's why it's very, very important. There is no other way of proving this. Even if I tell you 100 times, probably will never understand unless you feel what you're feeling today. Excellent. So the number of charges in 1 coulomb. So 1 coulomb is how many number of times of 1.6 into 10 to the power minus 19. And that question mark, obviously by division, comes out to be this. So that's the answer. Very good. Let's get going to the next one. Now let's talk about conductors and insulator. Very good. A lot of you agree with that. Yes, Sheetal. Yes, Yalini, Misha, Kirthiran, Uncharted, Chiranjeevi, Goen. Very good. Very good, Neha. Yes, all of you agree. Very good, Ronak. Anushmita. Yes, very good. So, we Enthuse FC South India definitely will plan it. Don't worry. Okay. Now, remember, examples of conductors are copper, aluminium, iron, silver, gold. All these are conductors. When you apply a potential difference, that means whenever you connect a conductor to a battery, they immediately allow the flow of charges and current flows through it. Now, what is the meaning of flow of current? Well, that means the charges are flowing. Now, what's so special in a conductor? Well, it has a lot of free electrons, a lot of jobless electrons not attached to their ohms. The moment you show them a potential difference, the moment you connect a battery, these electrons are like, hooray, let's move, and they start flowing, and that's when current happens. But in case of insulators, they are in home quarantine. What's their home? Atom. The atom won't leave those electrons. Even if there is a voltage, the atom will be like, hey, you can't leave. Hey kid, you can't leave. You have to stay at home. You are grounded. That's it. You cannot leave. But the electron will be like, but. The atom will be like, no buts. You can't leave. You have to stay at home. So that's what happens in an insulator like rubber, wood, plastic, and most of the things around you. Yes, not many free electrons. Correct? Correct. Wow, Chiranjeevi, you are in 10th class. Interesting. Very good. Let's move on. Now, having talked about what is a conductor and what is an insulator, how do I charge it? Let's say this is a metal. You can see this is a screwdriver. It's having some metallic part. All right. Or this scissor. This has some metallic part. This has some plastic part. This is a non-conductor. This is a conductor. How do I charge this metal? How do I charge this insulator? Now each one has two ways. So remember, write it down in your notebooks. Charging a conductor or insulator. For conductor, for insulator. For conductor, for insulator. Okay. Now for conductor, there are two ways. For conductor, there are two ways. For insulator also, there are how many ways? Two ways. Understood, guys? Remember this. Charging a conductor or insulator, there are two ways each. For conductor, there are two ways. For insulator also, there are two ways. Now I'm going to show that to you. First, let's talk about conduction. Or for conductors, there are two ways. So first one, this is the first one. Alright, conduction. Now, what is the meaning of conduction? Conduct means, I'll give an example. Now like, sir, teach me electrostatics. Then I'll be like, okay, bacha, come here. So I call the student at my home and then I place my hand over him on his head. He bows down and I place my hand over him and I transfer all the knowledge of electrostatics into his head. And then suddenly he's like, yes, I am enlightened. And then he's like, hooray, I now know electrostatics. So by physical contact, transfer is happening. That is conduction. Correct. Okay, but I didn't actually give him charges, but it was just to make you understand. So I'll show you the demo, that way you will understand it. Look at this. This rod touches another conductor. It gives its electrons. It's giving him Ashirwad by touching. He's like, okay, bless you. And you can see that. Yeah. So this is how corona travels from one body to other. Guys, remember corona traveling? You touch somebody who has corona, this is that yellow dots are coronaviruses. Think of it that way. This is an uninfected person. This is how the virus travels from one body to other body via conduction. Is that clear? No problem, J. Stravanan 01. Yes, I hope now at least you are understanding, and whatever part you missed, you can watch the replay. Yeah, that's conduction. Very good. Okay, now the second part. Guys, this was conduction, right? Now what is the second way of charging a conductor? Oh, by the way, why do the electrons flow? Guys, that's allowed. For a conductor, electrons can flow. They have no problem. They are anyways free, remember? They're allowed, they're free. No restrictions from their parents at home. Remember, they can freely move. Okay, but what about the second way? That's induction. Yes, very good, Ninath. Now again a student messaged me. He's like, sir, please can you teach me current electricity and electrostatics? I was like, okay, I'll do that. Attend my YouTube classes. So right now that student is probably you. And then I'm like, I can't touch you. I can't touch you. But I'm just showing this. Tathastu, yes, don't worry. You're going to get all the knowledge. I'm not touching you. And the knowledge is getting induced without that physical contact. So somewhat similar. So you take a rod which is charged and you bring it close, but do not touch it. Do not touch it. Yes, social distancing. Correct. Social distancing. So with that social distancing, you are going to see, look at that. This is that dude with coronavirus. Example, okay? And then look at these, what has happened over here. Do you see these electrons are like, oh my God, there is a positive charge. Look at what these electrons are screaming at you and telling, oh, there is a positive charge here. Let me run towards it. But unfortunately, they cannot jump over here because there is air gap in between of them. Induce, it has induced. I am coming to that. Now, when these electrons have ditched their homes, look at that, these electrons have ditched their homes, there is a positive charge created over here. I hope you can see that. So the electrons have ditched their homes and you can see there is a positive charge created here. So these electrons have traveled like this. So these charges are called as induced. I have induced without physical touch. Induction cooker, induction charging, you would have heard. There is no touch, it's just wireless transfer. That is induced charge. Okay, and you can see this is the flow of who has flown? Electrons. Protons never flow, electrons will flow. Why they have flown? Because they see positive charge. They're like, oh my God, such a nice positive charge, let me go there. But it can't jump there. Okay, and what has happened as a result of this? There is separation. There is separation of charges. Understand that. There is separation of charges. Yes, I hope this is clear. Alright, is that understood, everyone? Understood? Okay. Okay, I hope this is clear. Everybody, now you will never get confused between conduction and induction in conductors. Induction cooker is something else that's got to do with magnetism and all that. Don't worry about it, Mareshwara Virapur, okay? Very good, minions. So that is induction, guys. Very good. Now let's go to an analogy. It's very similar. Like if you have, a tube full of some liquid and another tube full of some another liquid. Remember, the levels are always same. So if you add more fluid in one container, the liquid will flow to the other container provided they are connected. Something similar happens when you take two conductors. One has some charge, another one has some different charge. If you touch them, this conductor has some charge, this conductor has some other charge. If you touch them, charges will flow. Yes, charges will flow. And till what time charges will flow? Till not the charges should be equal, till their potentials are equal. Now you will be like, sir, what the hell is potential? Don't worry, I'll be teaching that to you in session 3 or session 4. But understand, the charges flow till their potentials are same. Just like you can see, the height measures the potential energy, correct? Height measures potential energy. So the heights in both the containers will always be the same, no matter what you try to do. So the charges between two conductors flow till their potentials are Same. Yes, potential equilibrium. Correcto. Now, let's go to insulators. Okay, now let's go to insulators. So guys, we saw for charging anything, there are two ways. For conductors, one is conduction, second is induction. Now, for insulators, let's say for example, let's just say for example, I take, this is a plastic pen, this is another plastic pen. Guys, just imagine, this pen is negatively charged. Okay, this pen that you see is negatively charged. I'm just telling you, example. This is not charged. If I touch both of them, do you think charges will flow from this pen to that pen? What do you say? Yes or no? Madhuri, just you can replay the part and you can just go 5-10 seconds behind and probably there will be no buffering or voice cracking. Yes. This is an apple pen. I remember that, Nina, that song. Pen, apple, apple, pen. Yes, I remember that. My God, one crazy viral song. Okay, so it will not flow, guys. Very good. It will not flow because this is an insulator. And in insulator, electrons are home quarantined. Remember that? The electrons are home quarantined. They cannot move. They won't allow. Yes, they won't allow the flow of electrons. So even if this has excessive electrons and these guys are uncharged, electrons won't go from here to there because no motion of electrons is allowed. Then you will be like, how the hell am I supposed to charge these plastic objects? How the hell am I supposed to charge this, plastic or wood or any other insulating objects? Very simple. Rub them. They won't listen. You rub them, and when you rub them, what is going to happen? Understand, every atom has electrons in their orbits, correct? These electrons will get knocked out. It's like somebody forcefully coming to your house and taking you away from your bed. Or maybe just imagine these kids in their house, they're just roaming around in the garden. And then the friends come and like, hey, come on, let's go, come on. They put you in a van and take you away. So something like that. So when you rub things, these electrons get knocked out and they get transferred. Yeah, it's like kidnapping them. Yes, I hope this is clear. So when you rub let's say an insulator like a glass on a silk or any other cloth, which is again an insulator, see, unless you rub, the charges won't transfer, and that's what is happening. You can see that. So maybe now you'll be like, sir, why the hell would the electrons go from glass to silk? Why not from silk to glass? This question would have been there in your mind for a long time. Just, yeah, very, very true. Extroverts taking introverts away from their homes. Very true. Lato ke bhoot baaton se nahi mante. Oh, Chaitra Reddy, well, we will have the coffee session soon. Don't worry. All right. So the reason for the electrons going from the glass rod to the silk cloth and not from the silk cloth to the glass rod is because the silk loves those electrons more than the glass rod. The silk loves the electrons more than the glass rod. Remember, when you rub two things and there are free electrons knocked out, both will want those electrons back, but one will want those electrons more than the other. It's like two guys fighting for the same girl. The guy who likes the girl more, assuming the girl likes both the guys 50%. So, the girl or the heroine is going to go to that guy. I hope that makes it very, very clear. Is that understood, guys? Oh, Kushi, you can take other cloths as well. But understand, not every cloth with glass rod will always give, the charges moving. I hope that's clear. All right. Yes. Hello, XX track XX. Welcome. That was rubbing, friction, actual transfer by rubbing. Okay, that was way number 1. I hope, Kushi, that answers your question. Okay, so you can take other cloth, but every time the charges might not move because maybe it's like this cloth and that rubber might have same affinity, same attraction towards those electrons. In that situation, both of them will pull back those electrons and both of them will get back their original charges. So that way you will not have a difference of charges. Okay, cool. Now, second one. Remember, first one is always touching. There are always two ways: touching, not touching, touching, not touching. I hope this is clear. So the second way is without touching. There was one pathetic song I remember a few years back, and that was called No Touching, No Touching. And that was so horrible. It was by Himesh Reshmiya, if I'm not wrong. And that song stuck in my head because there are only two kinds of songs a person remembers. One is really good and the other one is really bad. And I remember both. And that's a very unfortunate. Okay. So this is very interesting because a lot of you might think even without touching an insulator, you can charge it. And you'll be like, what the hell? I thought insulators don't allow the motion of electrons. Correct. But you can still charge them. And this occurs because of polarization of atoms. And this is a temporary phenomena. I'll explain to you what I meant. Now just imagine. Guys, for simplicity, can I do this? For simplicity. Home is nucleus. What is home? Home is nucleus. The kid at that home. Oops. This was home, which is the nucleus. Let's say we call it Pandu. So that Pandu at that home is that electron. Pandu at that home is that electron. And Champa. This is a beautiful Champa. Okay, this is Champa. So Champa is that external charge. Okay, this is external charge. Now just look at this example, you will understand it. See, you have this home. Okay, that's the nucleus. And what is Pandu going to do? Well. Our Pandu, that's here. And he is going to be roaming around the home like this. He just stays around the home. He cannot move anywhere outside. Correct? So Pandu is supposed to stay near the home. There is one rule on Pandu. You have to stay at home. You cannot go outside. Now Pandu happens to see this beautiful Champa. Look at her beautiful hair. It's so nice, right? Who wouldn't fall for this girl? So this is a beautiful Champa out here. Yes, this is Champa. And she is the external agent. Now, what's going to happen out here? This is the home. And where is our Pandu? Pandu is here. Pandu is like, he's going to roam around the house because he cannot go anywhere else. But he's going to roam around here more because he wants to be seen by that girl. He's going to spend a lot of time here. And then he'll spend very little time here. And then again he'll go back here. So he's going to spend a lot of time here. And that's exactly what happens. When you take a negatively charged rod, or let's say a positively charged rod, what is going to happen? That electron cloud is going to shift, but not ditch. It's going to shift, but not ditch. Understand that. Now, because of that shifting, don't you see the negative charges have moved and it has exposed the positive charge? So that's why you will see plus minus within the atoms. I hope this is clear. Understood? Yes. That's how it is going to act. Understood, guys? So as simple as that. So this is polarized. They have become polarized. Earlier, Pandu was at that house equally distributed. So there was no positive, negative effectively. But now Pandu is spending more time, or the electrons are spending more time on one side. So, you have positive on one side and negative on the other side. So that is polarization within the atom. Well, go look at. No, I'm not going to complete every topic of this lesson. After this lecture, I'm going to run away and I'm going to go to, you see this Pathfinder. This is where I'm going to find my path. I'm going to go to Himalayas, guys. I'm going to run away. That's it. First lecture, last lecture. That's it. I'm going to run away. Okay. I'm going to ditch you all. Yes, well, Gula, I hope it's okay. Yeah, you can find me in Himalayas and you can learn from me. Okay, cool. So let's solve some problems. Let's solve some problems. Okay, and here is the first question. These are some things which you have not seen. If a negatively charged aluminum rod touches a conductor, the conductor will be charged by what method? The conductor will be charged by what method? Okay, Uncharted already says B. Okay, interesting. Well, let's see. Interesting. Okay. Guys, let's see how many of you got the correct answer. All right, time to show it. And here it is. Yes, very good. B, conduction. And that's the correct answer. Very good. Excellent. If you take aluminium is a conductor, and you touch it to another conductor, touch, remember, touch is conduction. Not touching, no touching is induction. Keep this in mind. I hope this is clear. Alright, Shreyas Hebbare, Uttarakhand. I love that place, man. I love that place. Alright, here is the next question coming up on your screen. Which of the diagrams below best represents the charge distribution on a metallic sphere which is positively charged? And you take a plastic tube. Okay, so the red one is a plastic tube and you bring it close to a metallic sphere. Close, not touch it. Which diagram is the best representation? Remember, the plastic one is positively charged. Hyperblades, exams cancel honge kya? Yes, exams will get cancelled, guys. All the exams are cancelled. You can all chill out, party. Yeah, all the exams are cancelled. We are just having fun out here. Yeah. Hello SG Vines, you're Ashika. Hello SG Vines, I'm Shreyas. Okay. Alright, cool. Yes, a lot of you are saying D. Alright, let's see whether it's D or not. Okay. Yes, very good. Hello Meenakshi IIT aspirant. Hello. Okay, yes, that is the locked answer. Very good, guys. And I'll tell you why D is the correct answer. Look at that. Guys, you're taking a positively charged, oops, where the hell did it go? Yeah, you're taking a positively charged rod. This is a conductor. What will the electrons do? Electrons will be like, oh my god, positive charge, let me move. So all the electrons are going to come here. And who are they going to ditch? The protons, the nucleus. So that's how it is going to be here. The electrons move. This is charge separation. This is the flow of electrons. And these are induced charges. Remember, induction. These are induced charges. That's how it works. That's option D. Very good. Let's move ahead. Why am I teaching so good? My God. Guys, please now tell me. If a teacher teaches bad, that's a problem. If a teacher teaches good, that's a problem. Is it a problem? No, right? Okay. B and C were same. No. B and C were not same. Where the hell is my remote? Oops. B and C were not same. This is positive, negative. Okay. In a way, yes. Yes. Correct. Yeah, but not exactly same. But in a way, yes. Conceptually. Okay, cool. Come on, guys. Let's go ahead. Come on. Let's see. Come on. Let's see. Charging by contact results in both objects having the same charge. True or false? Guys, I just gave you an example. I gave you an analogy. Hello, Ramiza Z. Welcome. Okay. False or true? Well, the answer is false. Guys, I just told you, whenever you connect two conductors, charges flow till their potentials are same. Charges may or may not be same. Understand this. If you take two equal objects, yes, the charges will get distributed equally. But if you take a small object and if you take a big object, I don't think the charges will be the same on both of them. No, the charges won't be the same. Understand? So hence, if you just take two conductors and touch it, they will have same charge. Nah, that's wrong. They will have different, may have or may not have different charges. So actually, yes, I'm going to cover Coulomb's law next session. Hold on, bacha. Today is the first session. There are 6 sessions. Bloody hell, 6 sessions, guys. Tell me, on YouTube, I don't think there are any English channels which are doing this. Number one. Number two, I think even in offline coaching, guys, I have taught in many offline coaching institutes. Trust me, nobody gives you, very rarely they give. Some people do, some people don't. 6 classes, that too for free on YouTube. I mean, I should be out of my mind to do that, but still I'm doing it for you. Okay, yeah. Anyways, let's get going. And here's the next question. Okay, a person rubbing his feet on a rug or a carpet. What kind of a person does that? I don't know. Experience a shock after touching a metallic object or other person. My God, this example is before 2020. Remember, after 2020, you are not allowed to touch other people. Okay, so this was in 2019, guys. All right, so this can be avoided by. Yes, I'll make Muhammad Irfan everything, don't worry. All right, hi Sheetal, Adana, hello. All right. Satyendra, Wazim sir will be back for chemistry very soon because he's not well, he's suffering from COVID, he'll be back, don't worry. Nitya, so glad to know that. All right, okay. B, nobody's going to sell the carpet on OLX, no? Okay. So people are going to wear the rubber slippers. Which ones? Paragon, Bata, or I don't know. All right. Not wearing rubber slippers. Who is not going to wear the rubber slippers? No. Okay. I'm going to move. Okay. Sanitizing your hands with sanitizer. Nobody is going to sanitize their hands. Bata ka chata. Good one. Adidas. Who the hell wears Adidas slippers? Who is that rich guy? Find him out. Who is that rich guy? Just mark him. Kirtaharan A wears Adidas slippers, guys. My goodness, how rich are you? Oh my God, Americans. I don't think even Americans wear Adidas slippers, guys. I mean, really? I think even the brand ambassadors would probably think twice. Okay, so well, guess what the answer is? The answer is actually C. The actual answer is C, guys. Yeah. Now you might be like, what the hell? Oh, I thought I had to wear rubber slippers. Why the hell is not wearing rubber slippers is the answer? I'll tell you. Supreme slippers. Oh, I love that. And I think Hrithik Roshan was doing ads for Paragon slippers sometime back. Okay. Now you know who is this guy? Well, he's John Travolta. Okay. Now we're going to see what he's going to do. Well. Now look at him. You're going to see that. He's going to shake his leg, like literally, like this. And do you see what happened? Rubbing. And when you rub, one of them gets charged, other gets oppositely charged. So the mat got, in this example, positively charged, and this dude out here got negatively charged. Now, understand, these charges have nowhere to go. It's stuck within his body. It's stuck. He's wearing slippers. That's a non-conductor. Nothing, nowhere else to go. Unless he moves his hand and touches this. Look at that, shocked. He just got a shock, guys. Yeah, I hope you saw that. Yeah, I will do it again. Okay, so he rubs his feet and it gets charged. There are a lot of electrons. Let's fill him with electrons. Let's shake his leg. All right, I like to move it. Oops. Oh my God, there was a lot of electricity built on him. So let's move his hand. He's digging his nose. Oh my God, bad boy, don't dig your nose. Okay, so he is shaking his leg. Lot of charge built up. I like to move it. I like to move it. And let's move his hand. Oh my God, dirty hand. He was digging his nose anyways, but all right. Yeah, so you can see that. How it moves. So guys, had he worn nothing, I mean, not like he was wearing his pants and shirt, but not anything on his feet, then these charges won't get accumulated. They would have flown inside the earth just like it is flowing inside this. So that's why not wearing those rubber slippers will avoid that shock if static electricity builds up. I hope that is clear. Oh my god, Anusha Ramesh is literally trying it with her carpet at home. Okay, Anusha, I hope your mom doesn't think you have gone crazy, and please don't blame me for that. Yeah, okay, yes. What website? Well, this is FET Colorado, PHET. Just search for FET on Google, you are going to get it. A lot of animations. No problem, Paila Chaitanya, no problem. Yes, I just told about Jafar charging by friction just some time back. You can just replay it behind. Okay, cool. Yes, but by wearing them, you can avoid electric shocks. So if you touch a live wire, so please don't say now, so now I'm going to not wear any slippers and I'm going to touch live wires. Please don't be an idiot. Yeah, please don't do that. You will be very stupid. Understand that. Yeah. So if you touch a live wire, guys, you do not want the electricity to flow within your body and you getting your ready-made hair spiked out there. You do not want that. Okay. So you should wear rubber slippers so that electricity does not flow within your body down out there. Okay. Cool. Now, field emission and all that. Well, we don't have all that. Okay. Jafar in JEE syllabus. Okay. Now, last part of today's lecture. I hope you guys are having fun, and if you guys are having fun, shower some likes, shower some love, and if you want to study with me, do not forget to smash that subscribe button, smash that like button out there. All right. Cool. Let's talk about the force between inductors and insulators. Very good. Okay. Let's see. Yes, Sunil, today is the first class. Yes, bacha, this is the first class. Okay. A charged rod is brought near a conductor. It will, what will it do? A charged rod is brought near a conductor. What will it do? Will it attract? And that conductor was not charged. That conductor was not charged. Come on, think about it. Yes, Vijay Kumar. Glad you are having fun. What about yesterday? Sunil, yesterday happened yesterday and today is today. Tomorrow will happen tomorrow. Okay. Is the field due to infinite sheet in JEE syllabus? Yes, Ananjan, it is there in the syllabus and we'll be covering it also. Do not worry. Okay, and the answer is A. Very good. Excellent, minions. And let's see why is it true, and let's see why is it true. Look at this. Where is our charge rod? All right, this is our charge rod out here. Okay. Now, it's brought near a conductor. This is my conductor. What will happen now is you will see instantaneously the electrons will shift here and they will expose those protons. Correct? The charges are going to flow. The electrons are going to flow. Now, understand these electrons will experience the force of attraction. They will attract. Negative, positive, positive, negative will attract. Positive, 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 positive will repel. So there will be a repulsion. But who will be more? Repulsion or attraction? Attraction or repulsion? Who will be more? Obviously attraction. Why? Because they are close. They are very close by and this is very far away. So the net force will be nothing but attraction. I hope this is clear. How is there any charge on the rod? Khushi, it is given. There is a charged rod. Look at that. It is already given. There is a charged rod which was brought close to a conductor. I hope this is clear. Okay, cool. Let's get going to the next one coming up on your screen. Okay, come on, let's get going to the next question coming up on your screen. Now, a charged rod, okay, is brought near an insulator. Read the question carefully. It's no longer a conductor, it's an insulator. What do you think will happen? Glad you liked it, Neha. All right. Okay. Oh my god, Sanju Baba, look at that. Sanju Baba is saying all this was taught in your coaching in 15 minutes. So, Sanju Baba, let me tell you one thing. In our regular platform, we teach it like this. In fact, even more lectures are there because there are test series, discussions and all that. So, please guys, if you are a 2022 aspirant, please join Vedantu. The link for joining Vedantu is there in the description box below. Yeah. Remain stationary? Well, I doubt it. And the answer is attract. Now you will be like, what the hell? It was an insulator, right? Hold on. I'll tell you what happens. This is again a rod which is charged. It's given, it's a charged rod. And then you have an insulator. This is your insulator. Remember, there is polarization. Remember that Pandu roaming around that house and finding that champa? Same thing is going to happen, same story. So negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive. Oh my god, this is looking like COVID negative, COVID positive. Okay, so now why this negative, positive came? Because the electron clouds have shifted. Okay, the electron clouds have shifted. Okay, thank you Khushi for all the love from Maharashtra. And even my hometown is Maharashtra anyways. Alright, so guys, understand all the negative charges are closer by a small teeny mini amount than the positive charge. So the force on the positive charge is, because they are far away, alright, they are far away, is slightly less than the force on the negative charge. I hope this is clear. Every negative charge is closer than the positive charge by a minuscule amount, small amount. That small difference for so many charges will make a difference. So that's why there will be attraction between this insulator and this rod. Even though you might feel, no, it's an insulator, it will not flow. But guys, tell me one thing. Yeah, Chacha Reddy, there is no reduction in the syllabus. Tell me one thing. Is this attraction more than what you would see in an inductor? Is this attraction more than what you would see in an inductor? Yes or no? Think about it. Come on guys, think about it. Yes. Is it going to be more or is it going to be less? It's going to be less. Very good. And let me show that to you. Out here, the same thing, and I have another simulation for all of you. I have a balloon, yay, nobody's birthday, but still I have a balloon. What am I going to do? I'm going to rub it on somebody's shirt. Let's rub it. Look at that. I rubbed it, and do you see what did the balloon get? It got some negative charge, and this dude got all these electrons transferred from here. I'll show it to you again what I just did. So equal positives and negatives, equal positives and negatives, neutral, 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 neutral. Now I rub it, electrons went here. So this became negative, this became positive, correct? This became negative, this became positive. Now look at this wall, it's neutral, right? Okay, let me rub more. Oh my god, a lot of charges on it. Let's see what happens when I take it near the wall. Observe carefully. See what is happening. Look at those electrons. They don't like these electrons. They don't like these electrons. Do you see that? How they are moving away? Do you see how they are moving away? And when they move away, what is left over? What is left over, guys? What is left over? Positive charges. Do you see that? Yes, I hope this is clear. Yug, Rathod, I'm explaining this over here. Hello, Asmi. Alright, so the negative charges are moving away. I hope you can see that because negatives repel. And then what is remaining? Positive. And what will positive do to negative? What will positive do to negative, guys? What will positive do to negative? It will attract. So that's why this balloon attracts there. Yes, that's what will happen. So that's why they will attract. So this is an insulator, this is an insulator. Still they typify, they attract. Okay, cool. Very good. Excellent. Let's get going to the next one. Question coming up on your screen. Okay, and there we go. This is something which you have to think at home, and you should post the answers in the comment section below after today's session. Wow. Okay, so post the answer for this question in the comment section below. Do two positively charged conductors attract or repel each other? Now you might be like, hey, come on, positive will obviously repel. The answer is not so obvious. It's got a very interesting answer. So guys, no, the answer is not so simple. Rohan, no. Rana, no. So it's not a simple question, believe me. So think about it, post the answers in the comment section below. Alright, let's see who and all are going to post the answers. And yeah, please drop a comment out there below after the session is over. And those of you who are going to write the examination this year, crash course are starting again. And if you have missed any of the joining dates, please join it now, because you can even watch the replays along with notes, along with assignments, along with test series, along with test discussions, along with doubts, along with in-class doubts, along with the best master teachers, along with a good discount of 4,000 rupees. So you don't pay 10,000, you pay just 6,000 using this coupon code SHCC. So if you love me, please use this coupon code out there. And guys, do not forget to join the Telegram group so that you can get the entire PDF of today's session. And this is Pathfinder series where you're going to find your path. Yes, till you write, I hope before you write the JEE examination, the right path, and you crack it. And that's the whole aim of me coming out here. So guys, if you loved today's video, do not forget to smash that like button. Do not forget to share this video with your friends. And do not forget to hit the subscribe button down there. You guys love it? Yeah, very good. All right, monkey is present. Very good. Yes, Asmi, you can join the crash course and you can crash it. You can gate crash it for sure. Definitely. You can also gate crash somebody's wedding. Oh, but no weddings allowed because of COVID situation. Yeah. All right. Yeah. Yeah, good, free. It's based on induced forces. Yes. Bye-bye. Take care. See you guys tomorrow in the next session, lecture 2. What is it about? Forces, field, and all that. All right. See you guys. Tada. Bye-bye. Have fun. Good night. Oh, by the way, I forgot to tell you, tomorrow morning, Zero to Hero series. I just forgot. Oh my God. Zero to Hero series tomorrow morning on, check it out. It's there in the playlist. Yeah, check it out. It's there. All right. Upcoming live stream. See you guys tomorrow morning at what time? 7 o'clock. Yeah, please wake up. 7 o'clock. That's morning, not evening. 7 o'clock morning. See you guys. Be there. Do not forget. Tada.